Hello everyone, myself WARDHAN, and I work in Windows application development in .NET platform. So let's see what's the agenda for today. So today we are going to discuss all about exceptions and exception handling. So first of all, we'll discuss what is an exception. Then we'll discuss about the essential blocks, the keywords which we use for handling exceptions. Those are try, catch, and finally. Then we'll have a look into the System.Exception class, which we use to get information and give information about an exception. Then we'll learn about throwing different kinds of exception. Then you'll learn to define your own exception class. Then we'll learn few best practices to handle the exceptions. Then we'll know about unhandled exceptions, and then we'll end up with knowing about debugging the exceptions. So before I move to my first slide, I would like to ask you all. I would ask you all who all have used exception handling in your day-to-day life? I mean, in programming. Let's show of hands. Okay, so you all have used. Okay, so I would like to know from any one of you what do you mean by exception? Anyone? Sorry, can you be? Runtime errors are exception. Any other idea? What is an exception? One we have got any runtime error is exception. Okay, so let's see what was the definition of an exception. Whenever a member fails to complete the task it is supposed to perform, as indicated by its name, it is called an exception. So this is one of the thing which you told, that runtime error, that is a part of this whole statement. Because the thing which failed at the runtime was performing some task, had some name, which had some goal which it was supposed to perform, and which it did not perform. So let's jump into a demo and just look into a simple example of what an exception is. So let's look into the code first. We just have a simple function which takes a string value as a parameter, and then it returns an integer value by passing it as integer. So we use integer.parse value. So over here, parse is the member. So the task of parse, integer.parse, is to take a string and convert it into a integer value. So, and we are calling it with the parameter hello. So let's see what happens. Okay, so we get a exception. Format exception was unhandled. Input string was not in a correct format. So this is right now this is just a message. We'll talk in detail about these all messages and all. So for now this is just an exception. So integer.parse was supposed to convert this string into a integer value, which it could not do. So this is just an example. Now you can imagine of anything, like suppose you are creating a class. You have some property set for a class, and now you want to perform some action on those properties, and it fails. So that will give your own kind of exception. Okay. The task which it was supposed to do and it could not. So now let's see into the building blocks of the exception handling. The first, the the try block. So try block contains code that require common cleanup operations. So what do we mean by common cleanup operations? Like anything, like suppose you start any process, you open a file in a try block, in anywhere. So before you end up all the tasks, you want to clean up that process. You don't want that file to be open or that memory to be allocated always, and I mean, when it is not required. So we put the common cleanup operation, the tasks which require the cleanup operations. Then we put the task, the code that requires exception recovery operation. Suppose you know that you are putting certain kind of code over here, and you are aware that this will face at any point of time, this will face this certain kind of exception, and you know how to overcome that, how to recover from that exception. Okay. So in that case, we use the try block, exception recovery operation. Then a code that might potentially throw an exception. So you have a code, you don't have exact idea what exception it will throw, but you have some idea that this might throw an exception. So in that case, you usually use the try block. And what should a try block have with it? It should have at least one catch or a finally block associated with it, either of them or both of them. Now a question, how much code should be added in a single try block? Again, I would like to ask this question from you only. So what do you think, how much code should you add in a try block? Any answers? Sorry? Call to a particular method. So you expect that method to fail, to give a certain, in case it fails. So I mean, and how much code do you think you should? I mean, is there any bound or? What could be the case? I mean, why should we? I mean, what should be? Okay.
These are the exceptions that we are going to.
Okay.
So in that point of time, we will just use only one flag.
Okay.
But if I'm completely unaware of what are the codes, what are the things which I am going to put inside try,
Mm-hmm.
I am not aware of what exception I would get. So in that point of time, we can also associate the entire code in single try.
Okay. So as per Nishant, I mean, if we are aware of that, we are getting certain kind of exception in particular bunch of code, we'll put them in a try block. And also in the case when we are not certain about what kind of exception may be thrown, we put the whole chunk in the try block. Right? No? Yeah. Okay. So basically in the try block we think of two things. Suppose if you have multiple lines which may throw exceptions, and you have I mean, those multiple lines can throw same kind of exception. Okay. So we have multiple lines, and multiple lines may throw same kind of exception. And for those multiple lines, if suppose you want to operate differently on after catching the exception, you want to operate differently on those lines. Suppose on a particular line for the same exception you want to do something, but for a particular line for the same exception you want to do the different thing. So in that case you will have different try blocks. Apart from that you can have same. But I'll get back to your point where we are not certain about the exception and we put it in the try block. So let's see a simple demo of try block as well. Again, we have a class that try, and we have a function how try can be used. Let's see. We have just simple code over here. I mean, this is blank code, which shows in different in how many different ways we can use the try block. So try block can be associated with a single catch block. it can be associated with a single finally block, or it can be associated with multiple catch blocks and a single finally block. Okay. So these are three different scenarios where, how we can use the try block. Okay. Coming to the next block, which is the catch block. So catch contains code to execute in response to an exception. Since we have a catch block, it will always be, it will always reach a catch block's content only in the case when we'll have an exception thrown. A try block can have multiple catch blocks. We'll come to this, where we'll see that we can handle specific exceptions, and we can handle general exceptions with System.Exception type. Then the expression after catch keyword is the catch type. You might have seen me writing that catch ex as exception. So that exception is the type. We'll discuss about it. What can be the different types of exception. Then in case of multiple catch blocks, the CLR searches the type from top to bottom. So suppose you have file not found exception, then you have system.io exception, then you have something, then you have catch ex as exception, last one. So it should be the most base class should be at the bottom. Suppose if we put the first block as catch ex as exception, and then we put the second block as catch ex2 as file not found exception. So in that case, what would happen? Since every exception is derived from exception class, in the first, it would never reach the second block. Every exception would be handled in exception. So we'll have to keep this in mind, that top to bottom approach. Now, what do we do in a particular catch block? We have three options. Either we rethrow the same exception which we got. Second, we can modify it, we can enrich it, we can put data, we can put your own data. Then we can throw it to the higher call stack block, so that the other developer which is using your code can have more information. Or the third point, which is let the thread fall out of the bottom of the catch block. So we use this as well in certain scenarios, but we'll get to know what are the do's and don'ts for this. Let's see. So again, we have catch class, then how catch is used. See, we have multiple catch blocks over here, and we have the last one as ex3 as exception. Let's make it the first one. You see, catch block never reached because system divided by 0 inherits from System.Exception. Okay. So the base class should be at the bottom. So this is one kind of catch. Then we have this function which generates an exception, divide by 0 exception. And what we do over here is we call this method try call stacks, and we divide this number by 0, so that leads to an exception, and then we throw that same exception. So let's see. So now we are in the test call stacks method. We have this number. We try to divide it by 0. We get arithmetic operation resulted in an overflow. We throw that exception. So what do you think, since we are throwing this exception, what should happen to this finally block? It would execute, correct? So we'll throw this. So after throwing this, this will execute the finally block. So in finally block of test call stacks. Then we go to the, right now I'm solving the exception. I mean, basically we should have exception recovery code over here. So this is how we send, I mean, we throw one exception to the other caller function. And next we have this unhandled exception. We are just calling this exception. We'll throw this and let's see what happens. So when we throw it, we just have this exception. It doesn't move side because it doesn't find another catch block in the upper level. So now in this case the finally block was not executed, as you would have noticed. So next we move to the finally block. So it contains the code that's guaranteed to execute. We have just seen it. So mostly contains cleanup operation required by action taken in the try block. Since we discussed in the for the try block that it can have code that requires cleanup. So that cleanup is done basically in finally block. Code in catch and finally block should have short and should have likelihood of succeeding without itself throwing an exception. Okay. So you have your code in the try block and you catch it, or in the finally block you don't want your finally block to throw an exception instead. However, we use inner exception concept in case we get a exception in the catch or the finally block. So just a quick look at the finally block as well. Just the UI. So finally block, we have finally class. So how finally is used, we have a function. So right now we are in the try block, we will open a file which will be sent in the parameter, and then in the catch we are handling IO exception, and we'll do whatever recovery code is needed, and then in the finally we'll close the file if it is open. So we provide a path with file name. And file was open, so in any case, even if the exception occurs, the file would always be closed. That's our main concern. We don't want our files to be open in corrupted states and all. Yeah. What if, yeah, so that means there is something very seriously wrong with your application.
You don't have to write
Yeah.
finally block. Shouldn't write your code first thing.
Okay.
After that, we are trying to close that.
Okay. So here,
If you say none rather than
yeah. So I mean, if you comment this code, then it will definitely fail. If suppose some error occurred while opening the file, so the file is not open yet, and we are trying to close it.
yeah.
So that's the reason we have added this line. If fs is not nothing, in C# you'll add it's not null.
By mistake I haven't added that. I'm not checking
Right.
none for that.
So that's your mistake you have already stated. So you need to, as I said, I mean, if you are getting your exceptions in catch or finally block, you need to reconsider your application seriously, because that is a bug, and that needs to be handled.
So why should I have there if you have just put it down that file open inside that.
Okay.
It might be that you can also check whether fs is none or not. After that you can perform the read operation.
Okay.
Then why you put it down there in bracket?
For this one,
Yeah.
suppose
If you are not going to
why I'm opening the file in the try block.
No. I'm saying that here you are trying to open the file. Suppose
Okay.
the file not found exception is there.
Okay.
So it will set automatically none to
Okay. Okay.
So it might be case that you use that if is not equal to null, then you can perform the read operation or write operation, whatever.
So in the try block you are saying?
No, no, without try catch.
Without try catch you are saying?
Without try catch.
So suppose you get a file not found exception. So how would your code proceed beyond that point?
So suppose
You'll get an unhandled exception. If file is not found, you'll get an unhandled exception. So the application won't proceed from that point beyond. So that is the reason try block is used. That is the reason we are closing it in the finally block. Okay. Okay, so we have discussed all these, how the code in catch and finally should look. Now we'll look into the System.Exception class. So this is base class for all exceptions. All the exception which we create or which we just catch is derived from System.Exception. So that's the reason when we give catch ex as exception, it catches every exception, each and every exception. All user and system defined exception derived from System.Exception class. We have two classes. We have two application exception and system exceptions, which basically means which was originally created to state that all the system exceptions would be inherited from system exceptions and all the application exceptions should be inherited from application exceptions. But current date, the scenario is not the same. I mean, we have a messed up environment where we have exceptions inheriting from both of the classes. So right now it has not, I mean, it doesn't have its meaning as clear as it was meant to be. So here are a few important properties of System.Exception. First is message. The message is the message you set for the exception. And this message won't be seen by the user. In case of unhandled exception, it would be logged. And you need to keep in mind that only the programmer would be able to look into this, this message. So this needs to be as technical as you can make it. Then you have data. We'll see in the demo how data is very useful in case of providing your necessary data point for the exception, why it occurred and all. Source will give you the assembly from where the exception originated. Then stack trace would give you each and every line where the exception originated and traveled from one block to other. Target site would give us more information on the functions and all where the exception occurred. Help link will learn how we can set help link, how we can use it. Then the inner exceptions, which which we can use in the case when your code fails. This should not always be used, but in certain cases when your code fails in the catch or the finally block, and you know it that it will fail, then you can use this inner exception. So let's quickly look into these points as well of throwing exception. While throwing an exception, you need to consider 2 points. So what exception derived types you need to throw? Suppose you are creating your own functions and you need to throw exception. You want to make that meaningful to the person who is receiving that exception. Suppose you are dividing by 0. You don't want him to see some file not found exception. You want to say him that this is a meaningful exception. Then what string message you are going to pass to the exceptions constructor type. Again, as I said, this message would be everything which, this could give you as much detail as you can send to the developer who will be looking at the application. So for this one, I'll explain a scenario which we are considering for this one. We are having an aircraft flying. Okay. So, no, it's landed, and we are increasing the altitude of the aircraft through this function, increase flight altitude. So this would increase the altitude of the aircraft. So what would happen to at certain point of time, say I've kept the limit as 30,000, my flight can go till 30,000 altitude. So what would happen if it goes beyond 30,000? It should obviously, it's not doing what it's meant to do, so it should throw an exception. So we'll see how we'll use this analogy in the examples. Let's look at the code first. So increase flight altitude, we have this function which calls a function in look into exception class, which on increments of 5,000 increases the altitude of the flight, and we use this increase altitude function to increase the altitude of the flight. So if the altitude is the property of that look into exception class, so we'll increase this altitude. So if the altitude is more than 30,000, we'll throw an exception, and we set the message, you are flying too high, which in reality should be very technical. Then we add these points, we'll come to it later. Then if it's not the case, if it's normal, we'll increase the altitude of the flight, and we'll just state the current altitude. So let's see. Current altitude is 0, and increase by 5,000. Then we get a exception. You are flying too high, and this is an exception which we have thrown from that function. So I print the exception message. Now we'll look into different properties which we discussed just now. So target site. Just we'll look into the we'll get to the exception, and we'll check the property for target site. So this is my exception object. Target site, and if you see the declaring type, you get the name look into exception class, and full name understanding exception, which is the solution name, then look into the exception class. Similarly, you have different details over here which you can use. So this was next. Let's see data property. If you would have noticed, I have added few data. So data is just a dictionary collection. So you can add as many key value pair as you want. So here we add 2 key value pairs, timestamp and cause, and we try to look into it. So once we have got the exception, we'll iterate through the dictionary values, and we'll check for the values which are there in the exception. So 0, 5,000, 15,000. Timestamp at this point of time the exception occurred, and the cause, the pilot must be sleeping. Okay. So similarly, the source would give you the assembly of the exception. So this is the assembly name. So right now it must not be making any sense to why do we need to see this assembly name when we are in the same project. But when you work on a class library, this would be very critical information to know from which assembly it was thrown. And all. And stack trace is a very important property. It will give you all the detailed information from where the exception occurred and crawled up. So let's see. We just use this stack trace property. We call this increase altitude function, and once we get an exception, we throw the same exception, and then we'll check for the the stack type. Sorry, the stack trace property. So if you see, the whole stack trace is given over here. Like, I mean, this is the last point where the exception was thrown. Line 124 exception handling. But if you look into it very carefully, you'll see like the application occurred. The exception occurred in some other class, but it's showing exception handling VB line 114, and the last point line 124 where it was thrown. It's not showing its original the place where it occurred. It actually occurred in look into exception class. Okay. It occurred over here, line number 8. But this information was missing in the stack trace. So for good or bad, this is how it works. If you create a new instance of exception, it makes the stack trace null, and it starts a new information from that point of time. So to avoid that, you can just throw the same exception without initializing it. So in that case, you'll have all the information. See, now you have this look into exception class, line 8, then it moved gradually. So you need to keep this in mind. This is a very critical point. Whenever you create whenever you throw an exception, it initializes the stack trace. You'll get a new data. So it might be confusing in cases when you are having your library and all. So it would be a pain for the developer to understand where actually the error occurred. Help link is a simple property where you can set a link. Suppose you have this library or your application which has some documentation or some link to documentation. You can set that link over here, and that can be seen. So this is, again, these informations are not for the end user, but for the developers who are working on the application. Now the inner exception. So with an inner exception, you can assign a sub exception. You can set an exception for a particular exception. So suppose you have this exception which occurred, the main exception, and as we know, if we throw a new exception, the old exception goes away. So we need to send this exception along with the information of the exception which occurred in the, suppose, in the finally block. So we'll provide that finally blocks exception in the inner exception. So through that we can handle all the values of the exception along with the inner exception over here. So let's see the function. We have this function, and along with it we throw a new exception, and we give the message. We can add more information. We give this message hiding information in inner exception, and then we set the inner exception. So this the second part is the inner exception, and which we send, and we can now we can have information of both the exception. Current exception is hiding information in inner exception, and the inner exception was basic exception due to which it occurred, you are flying too high. Okay. So now I think we are clear on throwing exceptions, and we are familiar with the properties of the System.Exception class. Now let's look into when we need to create our own exception class. So create your own exception class when the error is tightly bound to the class issuing the error. What do we mean by this statement? Suppose we have a class. Suppose we had this class. We have this flight mechanism where the exceptions, where the system exceptions won't make much sense, because adding height is not a crime for .NET. You can add as much height as you can, but for the particular class, it's not allowed. So in that case, we can create our own kind of exception, which will be more meaningful to the other developer which would be seeing that exception. Suppose I have a flight got too high exception, so that would make more sense than we get some random exception. Okay. Your exception class should be shallow and wide, as we have seen that hierarchy matters while catching the exceptions. So we should make the exception class wide, I mean not child with subchild exceptions. Okay. So here are a few points which we need to keep in mind to create your own exception class. These are a few points which you need to know. So first point is, I mean, not mentioned here, that your exception should end with the term exception. Like I'm saying, don't sleep exception. So that is a meaningful exception. Then it should derive from application exception. It can also derive from system exception, but then you'll be violating the rules. Then it should be marked with serializable attribute. It should define a default constructor. We'll see everything in the demo. It should define a default constructor. It should define a constructor that sets inherited message property. Like we throw an exception and we set a message property. So your exception class should also be capable of doing that. So that's the reason we define a constructor that sets inherited message property. Then again, same reason, like the way you attach the inner exception for a particular exception, your exception class should be able to handle that. So define a constructor to handle inner exception. Then define a constructor for serialization of your type. This is something you need to do. I mean, we are not going into much detail of this. So let's look into our own exception class. So this is our exception, aircraft too high exception. So let's see if we have met all the points. So this is marked with system.serializable attribute. Then it is derived from application exception. It has a default constructor. It has a constructor with inherited message property. You set the message name. Then you have the inner exception capability. Then constructor to handle serialization of your type. And then you can have your own properties and methods, whatever you want, as many constructors as you want. So now, since we have our own aircraft too high exception, let's not throw any .NET exception. Let's throw our own exception now. So if we see this exception, the call, we are calling this aircraft specific exception function, which increases the height, and this throws a particular aircraft too high exception. Okay, and we are catching the same exception. We can have EX as exception as well, but we apprehend that this function would throw aircraft too high exception, so we are having a specific exception being cached over here. So let's see. So our flight is flying high and crashes. So this track trace, we are just, so this is aircraft too high exception which was thrown. So this is a custom exception which successfully got thrown over here. So this was exception.toString which gave us these information. So now you know how to define your own exception class as well. So next we'll look into the best practices for the overall exception handling. Use finally blocks liberally. So finally block is a very powerful thing. It's very, it's very good, and you can use it as much time as you want because it's very useful. And you should use it to clean up all the operations, file opening, connection to databases, opening connection, closing connection. You can do it over here. Dispose objects to avoid resource leak. I've faced this situation in one of my cases. So I'm very particular about this, that you dispose your objects. Otherwise, if suppose you consider a case where you are creating objects and it gets into a loop, a very big loop. So at that point of time, the performance issues, the memory issues which your application suffers is drastic. So we should use often the finally to dispose the objects. Some of the examples which are language, your C# or VB.NET compiler which uses is lock statement, using statement. You must have used the using statement. So what happens over here? Like the using automatically closes the connection which you create, or I mean it disposes the object which you use. So it internally uses that finally block. Similarly for each, it internally uses the finally block to dispose all the objects for each. Now coming back to your point, don't catch everything. This is the this is the most misunderstood point. We usually give catch ex as exception and we handle the exception. But this should never be done. For any project, don't catch everything, catch only specific exceptions. Like over here we were aware that okay, the flight can go too high, so we were catching the flight gone too high exception. Similarly for your application, when you catch an exception, you are stating these 3 points. You expected this exception. So you somehow knew that this exception could occur, like I'm opening a file, so there could be a file not found exception. And you understand why it occurred. So that's the way you'll recover from the exception, right? In the catch block, you'll handle only if you know why the exception occurred, and you know how to deal with it. So this is the way you deal with it in the catch block. So suppose you are stating catch ex as exception. So what does it mean? You means you are aware of all the possible exception that may occur in that particular try block, and you are aware of all the possible ways to handle that particular exception. So that I think is practically impossible. So you should be very particular about this point. You should never catch each and every exception. You catch specific exception. If the exception, runtime exception, unhandled exception occurs, let it happen. During the period of development, this should happen, and that's the way you filter your bugs. But if you swallow your exceptions, this would lead to more serious application bugs. I don't think I need to explain a lot about the first point. I think you should all be very much aware of this point. Never leave an empty catch block. Never ever in life leave an empty catch block. You'll never get a situation where you need to leave an empty. This is not Harry Potter, which rotates stick and all the exceptions are gone. This exception handling is for you to use the knowledge of the exception, the error occurring, and you need to handle it. How you can handle it in the best possible way, not to just you have the error, you vanish it. So never leave a empty catch block. Always try to catch specific exception. We have discussed this. Then catch a System.Exception and execute some code inside catch block, and as long as you rethrow the exception. So catch an ex as exception, and you need to perform some operations, like suppose you are serializing a particular file and you break in the middle, you get some exception in the middle. So if you leave the file, it gets corrupted. So in the catch block, you can first move the pointer to the particular point. You can fix that, and then you can throw the exception again. Otherwise, the error wouldn't be known. Now the unhandled exception, we have seen many. So if no catch block matches the thrown exception type, an unhandled exception occurs. So the CLR sees from the point where the exception occurred, it first looks into the call stack and checks for the catch blocks. If it finds finally that there is a catch block which would handle me, it would throw the exception. Otherwise, it would throw an unhandled exception. In that case, the CLR would stop your application from executing, and it would most probably get logged in the event log. So I'll just show you the event log, how it looks, and how you can make use of this event log to get information. My computer, manage. It'll take some time. So this can be used in the cases when at the client's end your application is crashing. So you can use, and since you have not handled the exception, you can use this Windows log and application, and you'll have all the EX, that exception details over here. So let it load. Yeah. So this is some error occurred in some application. So you'll have all the information which you provide logged in this. So you can make use of this event log. Apart from that, you can create your own application log, which would log the application and which would give you the information what happened in the application. So now the last point, debugging of exceptions. So you can enable the exception to break the flow when it occurs. I'll show you in Visual Studio from where you can enable or disable it. Helps in finding the exception being swallowed. You can add your own exceptions. Let me explain this practically only. So in the debug menu, you'll see this exceptions. Go to the exception, and you'll see all the CLR exceptions. Now, what does this thrown means? If you select this, suppose I select file not found exception. So what would happen in this case is the application would break as soon as it gets to that point of time. So it would help you in debugging. It won't go in the catch block, but it would simply stop. So let's see, we had this code for file not found. We can modify it. So in the finally we had this code. So let's make it open. And this was in C temp. Let's delete these two files. So we are forcing it to throw an file not found exception. So let's see what happens when the file doesn't exist. So if you notice, it never went to the catch block. Okay. It broke over here only. So if you uncheck it, if I uncheck it over in the debug exceptions, it would go to the catch block. But still, if it is not handled, if your exception is not handled, it would again break normally. So you must be thinking why we need to break the application when we have already used the catch block. Yeah. So suppose a case when you are using a custom some library, okay, and you get a bizarre exception. And you have no idea from where that exception occurred, because some guy swallowed the exception using catchy x.exception, and then in the catch block, he just performed something and he never threw it again. So you have no idea where the exception occurred. So in that case, you just need to focus on which exception might have occurred and check it over here, and the application will break at that point of time. So that will give you a lot of data point to handle that particular scenario. So apart from that, from add, you can add your own exception which we created just now. You can add that over here, and it would appear in the list as well. So then we can set the properties for them as well. So okay. So I think we are done with all the topics. So any questions in this discussion, or any doubts or any queries regarding any exception points? No questions? Okay. Thanks a lot, everyone.